All right, Jared, what are we talking about this week on episode 2 of Source Decoded?
So today we're actually going to talk about some great stuff. Some of the most exciting stuff actually that we didn't even really discover till earlier today. You know, the interesting thing is about JavaScript is that you think you know the language and then you don't know the language. And then you think you know the language and then you realize you don't know the language. So it's actually a good thing to actually try to teach it, because then when you teach it, you need to make sure that you're right. And today we were messing with classes that we have at our job, and let's just say it didn't do what we thought it should have done. And that's because we were trying to make JavaScript into a classical inheritance, and maybe we shouldn't. So we're going to discuss all of that. We're going to discuss prototypes, inheritance, and literals, and probably in reverse. But that's what we're going to talk about today. So let's talk about
We're going to start with
the different literals, okay?
Okay,
Which color do you want?
I'll be blue.
Okay, you're blue.
So last week we talked about the fact that everything is an object, and this kind of goes along that discussion. This will extend, episode 2 extends episode 1. Go figure.
Imagine that.
Alright, so JavaScript has a few primitive types that we mentioned last time. The ones we're worried about are the number, boolean, array, object, and function.
So how about one of us writes the literal on one side, and the other one writes the...
Let's actually start with the constructor, because every object has a constructor, right?
Okay, let's do it.
So we'll do...
That's a good point.
Draw a line, and I'll do constructors over here.
And I'll do the literals over here. Hope that's
Okay,
big
so
enough.
let's start with a number. Like you're probably familiar with in other languages, the constructor starts with a capital letter, takes a parameter, in this case an integer.
So now that is... Wow, imagine that. 2.
Now,
But you need to do a new on that, I guess.
yeah, I guess so. So we'll make a new number 2.
That looks silly.
It's pretty silly, yeah, but remember, this is going to turn into an object. Okay, so then we can have a new boolean.
Correct. That would be equal to true.
True. This is also an object. Alright, now you're laughing at us, so we'll get a little fancier. New array, and then this takes a list of arguments, so I'll go A for Q.
Okay, he's trying me here. So what we're going to do is A, 4, and Q. So you notice that this is a lot shorter. There's a purpose for this.
These are exactly the same. You do this in your interpreter, it's exactly the same result, okay? What's next? An object. This is one of my favorites. My apologies for really bad curly braces. They weren't made to be written, I don't think. Let's say...
Also, but you're now doing the literal, and I get to do that.
Oh shoot,
See,
you're right.
you have to do the hard one.
I messed up. New object.
You get it simple like this.
And
And you just do a constructor.
I'm not gonna fill this one in.
Yeah, so you don't get to do anything fun. But that is equal to that. And that is just as bad as Ben was saying, so let's make that look a little better. There we go. Kind of.
That's an object literal. Curly braces make an object. You've probably had experience with JSON by now.
Yep.
That whole concept of JSON rests on this right here. JavaScript object notation.
Yeah.
Okay, and then there's one more. This one comes with a word of warning. Never do this in real life. You should never use the function constructor. Apparently, Jared told me earlier, this is how JavaScript started out. If you wanted to make a function, you had to use
The
this
constructor.
constructor. If Brendan Ike is watching.
I hope we're right.
Okay, well.
But it's good to know where it starts from, because everything does get funneled through this constructor, the function, because if you're to write a function in a function literal, like he's about to do, so he's just writing a...
So this is function with a capital F.
And it takes two arguments. It takes well, not two. It takes a variable amount at the beginning of what the argument names are, and then the string is a body.
arg1.
Yeah, which is a string. You're just naming them, so you're giving them names.
And then the function body goes in as a string.
Correct.
You can see why this would be awkward and you wouldn't want to use it.
And that also becomes interesting because then it's just like eval, and that's why it has the same evil as eval, is because you can actually inject it with the string literals. So, we didn't even do that. We should do a string literal too. But the point is this is actually synonymous with function, and well, he said he has arg1, so that would be arg1, and then we don't do anything, ... Well, let's comment that out so you can test that. But this is the same as this, and there are actually two different ways to write functions, and we'll explain that in a little bit. But the point, let's do a string real quick, because a string would be pretty simple as well.
New string hi.
Okay, so that would just be hi, like that. So the point is there's this seems a little bit lengthy and verbose, if you ask me, and everybody cried, and I wish that they'd actually shorten the function down a little more. We keep saying that, but they're getting better and better. I hope that they move it to a, just something like this.
These letter keys on my keyboard are particularly sad looking. I count on them so often.
But this is the beauty of JavaScript, is they actually have, if you notice, everything's an object. This is the same as that. There is only one gotcha that I know of on here that's kind of interesting, and I don't know if it works with everything, but on the number in particular, if you were to write a number like this, and you were to say, is 2 an instance of number, you will get false. Yes, I know that's crazy, and you will get true on that, even though if you augment the prototype of number with functions, 2 gets them. So this is one of those gotchas in JavaScript. So
ignore that he said prototype. We'll get to that later.
Yeah, you'll understand in a minute. But just remember that it does do the same thing in your console, but there are a few gotchas and weird oddities with it.
It occurs to me that this is a little bit paradoxical because the interpreter is going to have to come in and evaluate this first.
That's true.
And turn it into a string, which it then hands over to the string constructor and then returns the same string. Anyway, you got that? Everything's an object. Everything actually has a hidden constructor under the hood. We just do this to save time.
Yes. Okay, so let's go get to functions now. So now we're to the fun stuff. Okay, so there's like we said, there's 3 ways to actually create a function.
I think you should erase the word.
Okay, yeah, do a jump. Okay, so we know of 3 ways that you can write a function. The first one is, like we just said, is what they call a function literal. So if you actually said a function, you could say function and then have the name of the function here, and then you have arg1, and then you write the body, so this something here, and then, you don't even need that actually in the function literal. And we'll talk about, this is how you write a function literal. The function goes first, then the name of the function, and then the args and the body and so forth. It does not need a semicolon because it actually pulls it to the top of every function. We'll talk about that in a minute. The second way, so this is another way, is you would say var, the name of the function. So these are going to be synonymous. And then you'd say equals a function, and then you'd say arg1, and you would then do the body, and these 2 are synonymous, as well as, like we said before, if you were to say var name equals new function a new function, and then you say arg1. Hope you can see this really well. We make our comment. That is the body, right? And that is it. So those are all the same.
Now, note here that the function literal in this part is right here. You don't have to give a function a name. This is an anonymous function that you've probably used in callbacks and things like this. We
Yes.
made a function here. We made this new object and type function, and then we happen to assign it to a variable name. But it's totally legal to just
Oh,
Not-
perfect.
not give it a name. So that's important to
So-
understand.
So this is that's what's really interesting is this here is actually, like you said this was an anonymous function, right?
Mm-hmm.
Because you haven't given it a name like we did up above. But you can actually do that and use that inside of this scope. We'll talk about that maybe in I don't know, episode 31 or something. But the point is these are the 3 ways that you do it. I'd actually advise one way, and I would probably get in arguments with lots of developers. I personally like this way, because what it does is it gets you in the mindset that functions are variables and they can be passed around. It also does not confuse people when, because, do you mind if we erase this real quick?
No, go ahead.
Let's do an example of this. We're gonna make this real quick. But let's say you had a var a, and this is just inside of something inside your code. So let's say it's kind of like to be continued type stuff. But let's say this is inside of a functions call, and you actually make a function. If you were to have var a up here, and then say I want to equal fn, so you want to get the result of fn. If you do it in function literal style, so if you were to say function fn, and then return something really quick like boo, this will actually run. It makes you, it kind of bewilders you, because what happens is
But you haven't even declared this. This hasn't even been declared yet. How is that possible? Your function, I mean the interpreter hasn't got this far yet, has it?
Right, well, it has, because what it does, it takes your function literals and it top loads it. So
the interpreter comes in and messes with the order of my code.
it does, and it really makes you mad. It does it also with variables. So let's say you have a variable, right? Let's say you had down here. You say what? Let's say you said. Let's do another thing. Erase this. So it not only does it with function literals, but it does it with every variable name. So inside your scope here, if you said down here, var b equals 10, the interpreter takes this b, top loads it to here, and says var b is equal to undefined. And then down here, it basically ignores that you put that there and says now b is assigned to 10.
So it declares it. It makes sure it's inside the scope of this function
Correct.
in the beginning, and then doesn't give it a value until I actually assign one.
Correct. And that's what gets people weirded out with for loops. Because when they're in the for loop, most people like to say for var x equals 0, right? What did it do to that var?
Remember, this is functionally scoped. It's not block scope.
Correct.
So this var is in the same scope as all of these.
Correct. So people they assume that this x, once it's out of it's just inside the scope of this for loop, and it's not. So we'd say x is less than some length, or let's just do 10 or something to give you the point, and then x plus plus. People assume that it's block scoped and that x is only defined in here, but it's not.
But if you said x equals 20 right here, this is the same x, even though you
Correct.
just said var there.
Correct, but you overrode it. Now here's the oddity. This gets weird. You said var here, so it's going to try to front load this. If you would have done this without this var, this would have been put onto the global scope. That's the first
Right.
problem. But since you mentioned var somewhere in here, it's going to top load this, and now it's local to the scope, and it's going to assign x to 20, and then you're going to assign x to 0 after you assign x to 20.
And then when you're going to get down here, x is not going to be what you expected.
It's going to be 10 now.
Yeah, okay, but we digress.
So, sorry. So the point is on functions, like we said before, the way I suggest to use it, if you notice that we had that function down here and we reference that function, it would compile because it front loads it. It loads it to the top. My suggestion would always to do functions in this format because it allows you to look at the code and read it and understand it.
The way the interpreter is going to do it.
Correct. This is exactly the way the interpreter is going to do it. So there's no kind of ambiguity. There we go. I figured it out after a while. And you understand as well as the compiler knows what's going to happen. So now I should come down and say var a equals function with some argument. Boo. Everybody has foo, bar, meow, cat, so forth.
We have to.
So this is how I suggest to write it. Now, should we go on to a little bit about why functions are special?
Yeah, we promised we'd talk about prototypes and inheritance, and we will get there.
Here we go.
But this is important. One more step along the way. I guess I could have left your function.
No, that's fine.
Oh well.
Have at it.
So var car equals. Oh no, let's not do that. We're talking.
Should we talk about the constructor
Yes.
first?
No, hang on. No, we need to talk about this other thing.
Okay, well, that other thing. That's right. What's that other thing?
Var foo. Sorry, I used foo. Equals function. Okay, now we have a function named foo. There are actually 3 ways that we can invoke this function.
Oh, good. Yes.
The first one is to say foo. That will invoke whatever's in here. JavaScript provides you 2 other ways. I can also say foo.apply and foo.call.
Yeah, you could actually call this. This is interesting, but you'd actually have to use it on the scope of the window, right? Or I guess you could just call it, but that would work. So put those back. Sorry, that's perfect.
Okay, so you're thinking this is silly and you would never actually do that in real life because it's just more work.
Do you know this? I just realized something. This looks like a function invocation literal. And this is actually what happens. It's almost like the implementation of the function is explained down here.
You're right.
So now it looks a little bit repetitive because you do have to call the function call again on those functions.
Okay, there's 2 differences here. arg1,
arg2. Perfect.
Okay, we gotta remember functional scoping for a second. And remember that the function has its own scope. Oh, shoot, is that the right way to explain that? Okay, these.
Oh, let's back up just for 1 second. Arg2. Actually, we'll discuss it. Keep going.
Okay. Apply and call don't actually take the arguments of a function. This is wrong because the first argument for these is the context in which the function will be invoked.
Correct. So there's 2 things we want to focus on. Where's another color? We need another color. Okay, I'm a different color.
Black and blue.
Okay, so what we want to explain here are 2 things. We're going to explain context and we're going to explain scope. These are very important things and they need to be understood. Scope is what's between this function, curly brace and curly brace. So its beginning brace and the ending brace is its scope. So this here is the scope of the function, which means all the variables in there stay in there, but they can see out.
Right.
So functions in here can see variables outside.
So the scope works like this.
Correct.
Between
brackets.
Curly braces like that.
Yeah.
But nothing in here can get out.
So now that we know what scope is, here's a good example. For example, if we had a variable var a equals 10, this here could say, this function could say return 10 times a. and that would return 100. So it can use the outer scope variables. But what's interesting is you can override those variables as well. So let's say we said var a equals 20 inside there. Now that would be 200 because it looks at its current scope and then uses that. If its current scope does not have it, it goes to the outer scope.
So this, by doing this, we're going to leave a equals 10 untouched.
Correct.
When we get out the bottom here, a will still equal 10 because
Correct.
we declared our own a insert.
So we were explaining block scope earlier. Most people expect block scope. This is function scope. So a is safe from us because we've declared our own a in here. We can modify a inside of here without having any effect outside.
And again, you can do this, but usually it's not a good idea because you're not going to be able to read your own program.
Correct. But just know how function scope works. And a lot of times, the only time I really do this is when events and stuff happen to be in the arguments. But the reality is if you understand scoping, you can do a lot. And you're not confused with what people do. Even if they do this, you still understand it fully. And you will come across coders that do that. So, with that being said, now we need to explain context.
Scope. Yeah, okay. Get rid of that. Every function has a context. Whether you know it, whether you gave it to it or
Right.
not, it has one. The name of that context is, better use black, this. This is a magical word that means the context of this function.
It should have been called context, shouldn't it?
That would have made more sense, but that's
Yes.
longer and more words to type.
That's right.
You can put stuff on this. You can say this dot boo equals boo
Wow, that's fascinating.
if you want. And I'm going to get rid of our invocations down here.
Because we'll get back to those invocations in just a minute.
Do I have to invoke that before it has its context?
Nope. The reason why is because every function that's declared without being declared on an object gets tied to the global object. So this, in this context, right, this will be equal to window inside of the console.
Yes.
And this is where a lot of people get bit, and we'll talk about that later. But this, when a function does not have a context, it automatically goes to null. So let me write something real quick with the blue.
When it doesn't have a context assigned.
Correct. So remember how we said we had different ways to invoke foo? We had this way, right? Well, let's do this the real way. So we have arg1, right? And arg2, we should probably just make them strings for now. So I invoke it like that. I can also invoke it like apply, but this is where you need to understand how apply works. If you
Actually, before we do that, let's demonstrate this.
Oh, that's
in a
good idea.
console.
That's a good idea.
Something you need to know
There you go.
is this concept in JavaScript of the global scope. Every JavaScript runtime has a global scope.
Yes.
In your browser, it's window. I'm just going to go single line here.
Okay.
Window. And window has a bunch of stuff on it, most of which we don't care about. So let's make our function. And in it, I will say this dot boo equals boo. Okay, so we'll run that. And it didn't return anything. Now window has a boo.
Is it foo? Yeah, you said foo.
Oh,
Oh no, you said boo. So foo. Did
oh,
you
wait,
invoke it
sorry.
yet? You gotta invoke
You're
it
right.
first.
So we'll invoke foo. And now we'll say window has a boo named boo. That was actually really
Perfect.
good because I proved that boo wasn't there beforehand.
That is good. You meant to do that.
Uh-huh. I sure did. So, foo's context by default is the global object, which in a browser is window.
Correct. And a lot of times, if JavaScript is now being used in more places than just the browser, And the global object is not window. But if you ever want to know what the global object is, there's actually a way to do that. And you could I'll write that function out real easily in just a minute, and how you can return yourself the global object. But let's go to the foo.apply. Now that we know that everything has at least the context will be tied to the window, right? Or the global object. When you use apply and you supply null as the first argument, that will by default put window as the context. As the context. So that would be the same as doing this. And that, if we did foo.apply again, whoop, I did that wrong. Apply, it's done with an array. And if we did this would be equal. These two lines that I've written just barely are equal to each other. In the browser at least. arg1 and arg2 finish the array literal. So those are the same. These two are the same.
Actually, those three are the same.
Those three are the same. Thank you. Yes, those three are. So those are all the same. Now let's do one more to know. You do the same thing with call. If you put null, supply null, then you just say arg. It's just a variable amount of params that you can put in. And it will stick what you put inside the function invocation.
So this is invoking foo with the default or global context.
Correct.
But we can invoke it with whatever context we want, and a context is just an object. So
correct.
Instead of,
let's do something funny. And the other thing you need to realize is even though a function is a variable and you can tie it to objects, it doesn't mean other objects can't take your function and apply it to themselves.
let's do that. Come over to the console real quick, and we'll show you this. So here I've got an object. I made a new object using the object literal that we just heard about. And then I'm going to invoke the foo function using apply, giving that object as the first parameter. So we'll run that. And the last thing we do is see what object.boo is. And now object.boo is boo. So my object, which started out as empty, now has a boo property because the foo function
Was just applied to it.
was applied, and it said whatever context dot boo equals boo now.
So if you could highlight, Ben, for us, if you could highlight, if you look at apply, you're passing in the obj, the obj, right?
Yeah.
You can look at that as saying when you say apply, you're really replacing all the this in that whole context. Not the whole context, but in the immediate scope of the function context.
Yes.
With the object.
So that would be and this won't be totally accurate, but it would be something like this. Instead of this dot boo equals boo, what the interpreter is essentially going to do is say obj
Right.
dot boo
Exactly. So it's replacing the this and that function in that immediate function scope with the obj that you invoked it in, the context that you invoked it in.
Yeah. So that's kind of what the magical this keyword.
And a lot of you may think, why in the world would I use that? Well, I find all sorts of uses for it. Start with do a new function equals function. We'll do arg1 again and arg2. And so what we're going to discuss here is the keyword argument. Arguments, if you want to know, you can just do a console. How about you do this real quick? Do a console log on the args of a function. Argument.
Okay, let's see, then we'll invoke bar with a A, B, C.
Perfect.
Okay, notice I haven't in my function declaration accepted any arguments. JavaScript is going to give them to me anyway in this arguments. This is a keyword also. It has special meaning inside of a function. So we'll run that. And what I got back is this array. It looks like an array anyway.
Appears to be an array.
Of the arguments I handed in. I gave in 3 things. I got a 3-member array looking thing back. But
what happens to this thing?
This arguments thing, as it turns out, is a weird duck, and it's not an array. And I'm trying to think of anything that I would want to do on an array that I can't do on arguments.
So, for example, if you don't copy, let's say we wanted to manipulate the arguments. So let's say we didn't know how many were passed because we had a variable amount of arguments, right? And we want to start popping them off and assigning them to different things. When you start messing with this argument, you literally are messing with what your references were.
Oh yeah, that's great. So an array has this pop function. I hope I'm writing big enough. Pop.
You can't even do this actually in arguments, but we'll get to that.
That's true.
But yeah, because it's really pretty much useless.
This would return the last thing that was put into the array. So this would return a 3 and then erase that out of the array.
Correct.
Okay. So even though arguments looks like an array, turns out you can't actually pop on it.
Here's a good idea. I think we should try this. I'm going out on a limb. I'm guessing what's going to happen. So you try it and see what happens. But if I were to say arguments, now you're going to need to put some arguments inside the function declaration there in the signature. But let's say arguments and go with the index 1 and equals null. Then let's actually console log what happens with that arg2. I'm guessing it's going to print out null. I could be wrong. But that's the kind of funky stuff that I assume that it's going to do.
Alright, so this looks pretty straightforward. I'm going to invoke this function with 3
Gosh, I hope I'm right.
And then we're actually going to modify that arguments array, replace what should be 2 with null. And let's see what happens.
Guess what? It was null. So what this is really weird, because if you start modifying this arguments keyword with values, it literally stuffs this variable with something else. That gets really...
Yeah, so it's actually messing with the arguments that got passed into the function. My 2 wasn't what I said it was anymore. It was null. So before you do anything with arguments, we need to turn it into something. We need to turn it into an array.
Correct. So this is if you really would like to know, this arguments is a special thing that is really tied. These 2 things are the same thing. That's what you have to remember.
Yes.
And for some odd reason that we don't know, they are. So if you start modifying the arguments thinking that you can do some special stuff with these arguments and manipulating, not a good idea. So what we often do, right, before we go off into the land of, you want to explain what we do? Or
Okay, so remember that we can apply a function with any old scope that we want.
correct.
And that arguments array, that arguments
Thingy.
that's not an array, is, oh shoot.
It has a length.
It-
It has the things that an array has.
It looks like a duck, it quacks like a duck, but it's not a duck.
There you
But
go.
we can take advantage of the fact that it looks and acts like an array and make an array out of it. So we're going to say var args equals, hang on to your hat, array dot prototype. We'll
This
get
is
to
this
that
is
in
going to be a
minute.
good segue.
Dot The slice, right?
Yeah, slice.
Slice is a function that every array has. Dot.
Yeah, dot.
Apply.
Yeah, or call, either one.
Well, I want to give it an array-ish thing, so.
Okay.
Apply.
Well, you actually don't even give it an array because slice is just 0. So I do call.
I'm going to do call.
Because we're lazy. We don't have to do that extra bracket.
Call. Now the first thing is the thing that we're acting on.
Correct.
So
the
we're
context.
going to give arguments.
Make sure people know this is a lowercase c. There we go.
Oh, hang on. Arguments.
Yeah.
Yes, arguments as the
right.
context, and then it wants a parameter, and we're just going to give it 0.
Yep, correct.
Because we're going to copy everything after from parameter 0 on and put it into a new array.
Perfect.
So by doing this, that doesn't make any sense to you. I should give you more credit.
You know,
it probably makes perfect sense. It didn't make sense to me the first 17 times I saw it.
Me either.
We now have a new array, and it's actually an array named args that is a copy of all of the arguments.
Now, if you were to say args1 and send it to null, it does not affect the variable arg2.
Args1 equals null, but still arg2. This arg2 still equals whatever
we
it
said,
was.
AB, I think is what we had it in the example.
We passed in there. Okay, so that's a real life example of why you would ever want to use that silly call thing.
That's correct.
Okay, so now
I think we could segue now into
we
prototypes.
can go into the prototype. Now, okay, the array is the type. It's the
function. It's the constructor.
It's the constructor. And it has this magical prototype property, which represents the set of things that is in common to every array.
Instance of an array, correct.
Every instance of an array. So every array has everything that's on this prototype, including this slice function.
Correct.
Which we called and used.
Slice is a lowercase 2.
I'm gonna let you take it from there.
Okay, so this is where it gets a little fishy and fuzzy, and I'm still learning.
Because it isn't already.
You can see, if we haven't muddied the waters, they are now muddy. The beautiful thing about functions is they do have this interesting prototype. So if I were to create a function, so let's create a function that we can use as a constructor. This is where we're diving a little bit down into inheritance a little bit. So let's just create a really simple one called var_char equals a function. So this is exactly how they would have done an implementation of the array. Okay. Matter of fact, let's do that.
You want to make the array?
Let's just make a short with slice. We'll make a short array. So if we were actually declaring, don't do this because it's not advisable, but we're redeclaring the array. So if we were to write the implementation of array, we would say array is equal to a function that takes, remember it takes, the whatever you send it, but we don't care, but we have the arguments keyword for our help, and we have a bunch of things. This is what they say inside of your browser. We'll do the same thing. There's some native code inside of here. Okay, so with this function, we want to give all instances of array the functionality of slice. Oh, thank you. Thank you, Douglas.
I do.
Crawford.
Anytime.
Okay,
There's
so
lint in your code.
so we want to actually say, let's take the array dot prototype and assign it a really neat function. And that function is going to be dot slice, and it's equal to another function. And it takes the start, and I think it takes the end as well. So you can say I want to start at index and end index, and then we'll say native code for now because I don't want to write it all out. That right there will now give us the ability to come down here. So let's say we wrote this all in line. We could say then var a equals a new array, and we actually have at that point a dot slice. and we can invoke it with 0. So if that didn't confuse you, I don't know what will. We basically, this is how the JavaScript inheritance should look. Now there's a couple of things that looked a little weird. First of all, this prototype and how every instance of the array gets this method. But that's how the prototype chain works. So let's discuss that. Now that we've seen how you construct it, let's discuss how it works.
Okay, before you do that, I've got another working example
Oh, good.
of how this prototype stuff works. So here I've declared a new car. This will be my car constructor. You'll call this function to get a new car, and it has this running property which starts out as false. I want the car to have a start function and a stop function, and in normal languages, in other languages you would expect to declare this in here somewhere. Public start equals function, something like that. That's not how JavaScript wants you to do it. You, outside the function, the constructor, you start gluing things onto the prototype of that constructor. So I'm going to add a start function and a stop function.
Now give us an instance of that.
So we're going to go ahead and run that. So now the JavaScript knows what a car is. I'm going to make a new car. And my car is not running, but I want to start my car. And now my car is running. And then I can stop it again, and it's false.
Okay, so perfect. So I think we got a full grasp on how the constructors work in relation to prototype and their instances. There's something I'd like to go over, and it's this new keyword. This is what you'd kind of expect from other languages with a lot of gotchas. But so what is this doing? We can actually write what this new operator does on the array, because what it does is it ensures that this function is executed in the context of the instance you're trying to create. So you're trying to create an instance of an array, so it creates an empty object, sticks it in there, and the array starts filling it with data. You know, the length and all these special properties. It then returns it back to A. An array actually has the prototype. Now this is where it gets interesting. The other thing the new operator does is it guarantees that you get sent back the instance of that array. Now let's talk about how the prototype lookup looks, right?
So while you're erasing that, I'm going to say what I think you just said.
Oh good. Why don't you translate for me?
In another way.
Okay.
When you make a new array or a new car or anything, what you start out with is the base of base objects, and that is an object. So you start out with an object, and then your car constructor is going to teach that object how to be a car.
Correct. So you're just
then give it back to you. So that new car or that new array constructor does the same thing. It starts out with an object, it teaches it how to be an array, and then it hands it back to you. So we can write that another way.
Let's write down your car example. What I can do is actually show you how you can actually create the
we can make a new car without ever using the new keyword.
Correct. So what you said in your car, so you actually had to do a new deal, right? But I'll just say, hey, I want to create a car. Is that fair?
Okay.
I want to create a car, and I can just make it empty.
So it starts out as an object.
That's just empty. It does nothing other than the base stuff.
There's nothing special about that.
But now I really want people to know whether it's running or not. And, well, we all know cars don't just start out, so we say it's not running.
Right.
But now, we could actually...
We need to be able to start this car.
So, I want to create a function. So I'm going to create a function on that car. And now I'm going to say this. Because remember, this function is executed in the scope, is executed in the context of this instance. Dot running. equals true. Right?
Yeah.
Am I the right thing? So now we actually have another. I want to be able to stop. Same deal. Boy, you hear that? It's like I'm squealing around corners with this thing.
Speaking of cars.
So, there is really...
We could teach this object how to be a car like this. And that's fine and good unless we want to make more than one of them.
So you're saying that we need a factory structure?
Doing this to make a car every time is going to get really tedious. So, boy, gosh, wouldn't it be nice if we had this function that could just teach a car how to be a car and call that function whenever we wanted a new one.
Oh, isn't that what you did with the new... Oh,
you're right.
So we created a function that just became basically a factory.
A car factory.
A car factory. So let's rewrite this. This real quick. What's interesting is we could use the prototype inheritance and use the functions, but we can also look at this. This is how easy we can do this. We can get rid of this, and we can come say, hey, we're going to insert, because we want all cars to act like this, right?
Mm-hmm.
So we're going to say, hey, we want a car is equal to a function.
You broke your own rule there. Oh, no, you didn't. Carry on.
Oh. No, I didn't.
Carry on. Okay, yeah, you're right. Sorry.
Okay, so now we say we want the car factory, so to speak, the constructor, to set these things straight. So what we could do is simply change all these old C's to this, this, and this, and voila, we have a constructor. So now instead of teaching an object to be a car in 15 lines, we now consolidated it to
we can
16.
Reuse this. This is all coming around to me as functional programming. It's brilliant. Okay, so in the context of, remember call or apply.
Yes.
Call and apply.
Mm-hmm.
To use this factory, we could say var c equals a new empty object, and then we can say car dot apply hand in C
Perfect.
as the context we're working on, and this one doesn't have any arguments. So now this C is going to be injected where this is, so these turn back into C's, and then when it's done, C knows how to be a car. But we've run this hunk of unformed metal and plastic through the car factory, and out the other side we got a car.
So you're telling me this is actually equal to saying var C equals a new car. Am I not correct? That's what you're saying.
You are exactly right. This is just a convenience that JavaScript gives you to help you think like programmers in most other languages do, of doing this, which is really just running a normal plain old object through a factory of a type, and then teaching it how to be that thing.
What's so wonderful is everything starts out with like this unmolded, I love that analogy, that the unmolded metal, and then out the end comes the car. I mean, this is just simply the metal, the glass, and then now give me a car. And that's the beauty of these functions on functions, is that you can say, hey, I want to apply this function in the context of this object. And all of a sudden you get all this functionality. That is power. And
if I must confess, this is something I understood about 45 minutes ago, just as we were thinking about it and digging into it this morning. Isn't that awesome? This is why everything in JavaScript is an object.
Yeah,
because it all starts out as one and just gets run through the array factory, or the function factory, or the car factory, or the whatever factory.
The point is, it's exciting, and I think we've gone probably overboard or overkill with all of this.
We were going to get into inheritance today, but that's just going to make my head explode.
So I think we're good, and we'll discuss more about inheritance later, and that is actually probably going to take us all next time.
But this is critical to understanding the JavaScript inheritance model. It's not what you might think. If you don't know any other languages, you're in luck. because your brain hasn't been muddied up with all of the nonsense that C++
The conventions of the past.
want to teach you.
Well, thanks for
Anyway.
watching the second episode and join us for the third.
All right, good night.